Hello everyone! In today's video we are going to talk about Karl Fischer reagents for volumetric samples. Do you want to know what the advantages are of one component versus two component reagents? Do you want to know which one is our best seller? Stay tuned and you'll find out. Let's start with a bit of theory. The Karl Fischer titration is the universally known technique for measuring water content. This reaction is what makes it possible, where there is a stoichiometric relationship between the iodine consumed and the amount of water in the sample. The reformulated Aquagent range from Scharlau for Karl Fischer allows you to measure the amount of water in many samples and at very different concentrations with reagents of exceptional quality. Some of the advantages of the new formulations are a more stable and robust factor, faster stabilization, and a more stable endpoint. That being said, are you unsure when to use a volumetric reagent or a coulometric one? In general, we will choose a coulometric reagent for water contents below 0.1%, that is 1000 ppm, and a volumetric reagent for water contents above 0.1%. In today's video, we will focus on volumetric reagents. You might be wondering, what is the difference between single component and two component reagents? Well, let's start with the single component titration. The titrant, which contains iodine, is added to the sample using a burette, reacting with the water present. This allows us to calculate the water content precisely. In this method, all the components necessary for the reaction are in a single reagent, the titrant. This allows the flexibility to use different solvents, such as dry methanol, which is more economical and dissolves the sample well, or our methanol fast, which reaches the titration endpoint more quickly. Now let's look at titration with two component reagents. In this case, the solvent not only dissolves the sample, but also contains part of the components necessary for the reaction. Therefore, the components are divided between the titrant and the solvent. This offers some advantages: faster titration, a more stable endpoint, and lower reagent consumption. Also, since this system is more stable, it does not need to be standardized as often. Even so, it is not as versatile or as robust as the one-component system. That is why the one-component system is the best seller. To finish, we are going to measure the water content of a sample in situ. Let's take a look. Today we are going to use the Metrom 390 titration equipment. Previously, we calibrated the equipment. We can calibrate the equipment with either a solid standard or a liquid standard. For this occasion, we have used the liquid standard Aquagent AQ0020 with 1% water, which is indicated for volumetric samples. For today's measurement, we are going to use a sample of UHPLCMS water. Here, we are working with a sample that comes from the well-known chemical Scharlau brand, specifically labeled as AQ0015. In the previous step, we carefully weighed the sample using a precise syringe to ensure accuracy in our measurements. Now we are ready to move on to the next phase, which involves actually performing the measurement itself. To do this, we first press the start button on the instrument to begin, and we enter the weight manually. The reagents we have used are our best seller, AQ0015 Complete 5, together with methanol fast AQ0011. By using methanol fast instead of a dry methanol, we achieve better solubilization and a faster measurement. If you don't know which reagent you need, you can contact our consulting team, and we will help you choose the best option.